In this video, we are going to see some of the NEET questions asked in previous years. So, the topic is P block elements. Question is match the compounds hybridization and shape with column 1 and column 2. Here the column 1, the name of the compound is given. The column 2, the shape of the molecules are given. Here the xenon compound XeF6, XeO3, XeOF4 and XeF4. Here the shape of the molecules are distorted octahedral, square planar, pyramidal and square pyramidal. We have to match the correct molecular shape of this compound. For that matching codes are given. Here there are 4 xenon compounds are given: xenon hexafluoride, tetrafluoride. Here XeO3, XeOF4 is given. Here XeF6, here it is a distorted octahedral structure, 4 corners, 4 fluorine, up and down 1 fluorine, 1 lone pair of electron. So XeF6 is distorted octahedral structure. Here XeO3 pyramidal structure, here the bonded 3 oxygen along with xenon. Here on the head 1 lone pair of electron, giving pyramidal structure to XeO3. And here XeOF4, here 1 oxygen atom and 4 corners, 4 fluorine, and giving the shape of XeOF4 as square pyramidal with 1 lone pair of electron and 5 bonded pair of electron. And here the xenon tetrafluoride are 4 corners, 4 fluorine on the top with 1 lone pair of electron, giving the structure of square planar. So XeF6 distorted octahedral, XeO3 pyramidal and XeOF4 square pyramidal and XeF4 square planar. These are all the structure. Now coming to the question, here the first one XeF6 match with the distorted octahedral. So for A it is 1. There are 2 choices given, A1 and A1. And second one XeO3, it is pyramidal structure, and pyramidal structure is third one is the pyramidal shape. So here the second one 3. So D is the correct answer. 1, 3 and 4, 2 is the correct answer. And XeF4 square planar, XeOF4 square pyramidal. So this is the D is the correct answer. The next question is, in which one of the following order is correct for the bond dissociation enthalpy of halogen molecule? Here bond dissociation enthalpy change during the bond dissociation for halogen, the different orders are given. So fluorine, chlorine, bromine, iodine. So we have to find out what is the correct order of bond dissociation enthalpy of halogen molecule. So in periodic table, the halogen group, the halogen occupies the position is like that: fluorine, chlorine, bromine, iodine. Here as the size increases, the bond dissociation energy size increases. On moving down the group, the size of the halogen, size of the atom increases. That is the general trend. As the size of the atom increases, the bond dissociation enthalpy lowered, that is decreases. Size increases, bond dissociation enthalpy decreases. So fluorine, chlorine, bromine, iodine. But fluorine, because of the repulsion between the bonded atom, always shows deviation because of the electron repulsion. Here the bond is much weaker, they shifted to that other side. So here the bond dissociation energy of halogen, as per the increase in size, decrease of bond dissociation energy. Here chlorine, bromine, then comes the fluorine, then iodine. Because of the larger size, iodine possesses lower bond dissociation enthalpy, and fluorine should come first because of the electron repulsion between the bonded atom, and here it goes to the last. So the order is chlorine, bromine, then fluorine, then iodine. Chlorine, bromine, fluorine, then iodine. So this is the correct order of bond dissociation enthalpy of halogens. So in the question given, The bond dissociation enthalpy of halogen size increases, dissociation enthalpy decreases. The fluorine makes the difference, so the A is the correct choice. Next one is, what is the basic structural unit of silicate? SiO minus, SiO4 4 minus, SiO3 2 minus, SiO4 2 minus. There are 4 choices given. The basic structural unit of silicate. The structural unit of silicate SiO4 4 minus. The silicon with the tetravalency with 4 oxygen. Here the negative charge is present in the oxygen. The electron which is not involved in the bond formation, negative charge SiO4 4 minus. So this is the chain structure of silicate, basic unit of silicate SiO4 4 minus. And so all silicates tetrahedral structure with SiO4 4 minus link. So the correct answer will be SiO4 4 minus. So in this question, the basic structural unit of silicate is SiO4 4 minus. The next question is, aluminum fluoride is soluble in HF only, hydrofluoric acid only, in the presence of potassium fluoride KF. It is due to the formation of dash. So different options are given, different coordination compound names are given. We have to find out what is the correct answer. Aluminum fluoride soluble only in hydrofluoric acid in the presence of potassium fluoride due to the formation of what coordination compound? We have to answer. Aluminum fluoride, aluminum 3 plus ion. Here the coordination number is 6, forming AlF6 3 minus. That aluminum fluoride, when dissolved in hydrofluoric acid in the presence of potassium fluoride, aluminum fluoride with potassium fluoride 3 molecules, in the presence of hydrofluoric acid, it forming potassium aluminum fluoride K3AlF6. So this is the coordination compound formed when aluminum reacts with potassium fluoride in the hydrogen fluoride according to the coordination number 6. So the answer will be aluminum fluoride soluble in HF in the presence of KF, and the compound name is K3AlF6. B is the correct answer.